Well, hello there, 7th graders. We are in section 6.6, which covers parallel and perpendicular lines. Now, I know you've heard what parallel and perpendicular lines are, but we're going to go over today how we can use them in order to write equations. You do not need to write this down right here. Now, in the graph at the right, the red and blue lines, okay, let's just look at this. The red and blue lines, they're parallel. Parallel lines are in the same plane, but they never intersect. Now notice what it says here about their equations. The red line has an equation of y equals 1/2 x plus 3/2. The blue line is y equals 1/2 x minus 1. What do you notice about their slopes? They're the same. That is your first key concept. You do need to write this down, that the slopes of parallel lines, non-vertical lines are parallel if they have the same slope, same slope, same slope, and different y-intercepts. Now, any two vertical lines are also parallel. So, an example, we can see in both of these equations, they both have the same slope of 2/3 and different y-intercepts. Therefore, the graphs of these two equations are parallel. In example 1, we're talking about parallel lines. I want to know, are these lines parallel? In order to determine if they're parallel, we need to find their slopes. In order to find the slope, we got to put them in slope-intercept form. So the first equation is already in slope-intercept form. The second equation is not. So let's do that. We subtract the 2x. That gives us negative 2x plus 12. I divide everything by 6, which gives me y equals negative 1/3 x plus 2. You will notice that the slope of the first equation is negative 1/3. The slope of the second equation is the same. Their y-intercepts are different. So are they parallel? Yes. These lines are parallel. Why? Because they have the same slope but different y-intercepts. Now we can use the fact that the slopes of parallel lines have the same slope to write an equation of a line parallel to a given line. To write the equation, use the slope of the given line and point slope form of a linear equation. So here we go. Write an equation for the line that contains this point right here, 5, 1, and is parallel to this line y equals 3/5 x minus 1/4. We have a point, 5, 1. We know that we have to write an equation that has a slope that is parallel to this line. Since parallel lines have the same slope, we know that the other line has a slope of also 3/5. Right now, I have a point, I have a slope. Therefore, I'm going to use point slope form, which if you remember is this. I plug in my y value, which is 1, my slope, which is 3/5, and my x value, which is 5. So my answer would be y minus 1 equals 3/5 times x minus 5. I want you to write it in slope-intercept form. Y equals 3/5 x minus 3/5 times negative 5 is minus 3. I add the 1. So my equation would be y equals 3/5 x minus 2. Double check to make sure you did it correctly. You do have the same slope, so that is correct. Y equals 3/5 x minus 2. I want you to try part B on your own. Pause the video and write an equation for the line that contains the point 2, negative 6 and is parallel to y equals 3x plus 9. All right, if you did it correctly, your answer would be y equals 3x minus 12. If you got that, you can skip this remaining part of this problem. We know our slope is going to be 3. I'm going to use point slope form. So if I plug in negative 6, I get y plus 6 times my slope, which is 3, times x minus 2. I distribute the 3, and then I subtract 6 on both sides, and that gives me y equals 3x minus 12. Now, the second thing we're going to talk about are perpendicular lines. Perpendicular lines are two lines that intersect to form right angles. As you can see here, both these lines form 4 90-degree angles. Notice that the slope right here is negative 1/4, and this slope is 4. Now, I will tell you right now that the key concept is going to be this. If you multiply, if you find the product of your slopes, it will always give you negative 1. So your key concept is as follows. The slopes of perpendicular lines. Two lines are perpendicular if the product of their slopes is negative 1. Now, let's step aside here. A vertical slope has an undefined slope. A horizontal line has a slope of 0. Those two slopes are perpendicular, but they do not have products of negative 1. That's why there's a separate line here for them. Vertical and horizontal lines are also perpendicular. So you'll notice up here in our example, if you took negative 4 and 4, negative 1/4 times 4 gives you negative 1. Therefore, the graphs of these two equations are perpendicular. Now, the other thing you're going to need to know is that the product of any two numbers, they're actually the negative reciprocals of each other. Negative 1/4 and 4 are negative reciprocals. So if I said my slope is 5, what's the negative reciprocal of that? It'd be negative 1/5. What's the negative reciprocal of 2/3? It's negative 3/2. You take the opposite and you take the reciprocal. What's the reciprocal of negative 1/6? The negative reciprocal will be 6. We flip it and change the sign. So example number 3. Which equation describes a line that contains the point 0, negative 2 and is perpendicular to y equals 5x plus 3? So let's take our equation. Y equals 5x plus 3. The slope here is 5. But I want a perpendicular line, so I have to figure out what the negative reciprocal of that is. So I have a point 0, negative 2, and the slope of this line, the negative reciprocal of 5, would be negative 1/5. I take the opposite reciprocal, negative 1/5. So now let's use our point slope form. That would be y minus a negative 2, which would give us y plus 2. My slope of 0, I'm sorry, that's not correct. Let's go back. My slope of negative 1/5 times x minus 0. That would give me y plus 2 equals negative 1/5 x. And now I subtract 2 on the other side. That gives me negative 1/5 x minus 2, which would give me the answer D. So what I want you to do now is using this point 1/8, I want you to write an equation of a line that contains the point 1/8 but is perpendicular to the line y equals 3/4 x plus 1. So let's go through this. We have a point of 1/8. I need to find the slope. Since the slope of this line is 3/4, I need to find the negative or opposite reciprocal of that, which would be negative 4/3. We now use point slope form. I plug in all my information, and now I distribute. Y minus 8 equals negative 4/3 x plus 4/3. I add 8. Y equals negative 4/3 x. Well, 1 1/3 plus 8 would be plus 9 1/3. So my equation would be y equals negative 4/3 x plus 9 1/3. Our last example, number 4, is a real-world problem-solving example about urban planning. A bike path for a new city park will connect the park entrance to Park Road. So here's the park entrance, here's Park Road, we have to connect it. The path, as you can see here, is perpendicular to Park Road. write an equation for that line representing the bike path. So I want to write an equation that represents this. All right, so let's go through this. What point is on this line? The point is 0, 4. Now we know that it's perpendicular to the other line. The other line has points of 4, 5, and 2, 1. So we need to find the slope, then to define the perpendicular slope to that. So the slope would be, let's see, 5 minus 1 is 4, 4 minus 2 is 2. That means the slope of the red line is 2. But my line, the path, is going to be perpendicular to that. So my slope would be what? Negative 1/2. And hopefully that makes sense because look, down 1 over 2, down 1 over 2. That's the slope of negative 1/2. So now let's use point slope form. So y minus 4 equals negative 1/2 times x minus 0. If we simplify that, I get the equation y equals negative 1/2 x plus 4. And we can double check that by making sure that my y-intercept is 4. My slope is down 1 over 2, and that does work.